Good evening. I am here to present our problem statement and this is to construct DFA starting with ABA, sigma equals A and B, and this is our input. We have a mathematical model here and it contains of Q, sigma, del, Q0 and F. Q is for our set of states, sigma is for our A and B, del is for our Q0 and F is for our initial and final state. As we can see, we have here a Q0, Q1, Q2, Q3, and Q0. For our Q0 is our initial state. For our Q1 is our start with A. For our Q2, start with AB. For our Q3, start with ABA, which is this. For our Q0 is our reject state. Del equals Q and sigma to Q. This is our transition table. We can get this answer by putting it simultaneously. So, for example, can we see a sigma A here? No. We cancel the sigma, and can we see a letter A here? Yes. So we put a Q1 here. So let's proceed to this one. Do we see a and B here? Yes. And this is Q2. So let's put it here. And so on and so forth. So this is our transition diagram. This is our initial state, this arrow. So we have here a Q0 to Q1, which is here. Q0 to Q1 is A. Q0 to Q0 here is B, which is here. Q1 to Q0 is A. So here. So we put a Q2 here. Q0 to Q2 is B, which is here. And the next one is Q2 to Q3 is A. Here, A. So the next one is this, the Q3, A and B itself, which is here. And for the last one is our Q0 itself again. This, we input the A and B here. So this is the start. And that's all for today. Thank you.
Strings ending with 100. So what does it mean? The DFA should accept all those strings end with 100. So let's get started. First, we put our mathematical model, and it consists of Q, sigma, del, Q0, and F. So we should get our Q. Q0 for initial state. Q1 is strings ending with 1. Q2 is strings ending with 10. Q3 strings ending with 100. For our sigma, we need to call the alphabet, so we put 0, 1. For our Q0 will be Q0, and for the F, this is the final statement, so it consists of Q3. So all all we need to do is to call our delta or our transition function. So for that, we create transition table, and to make this one, all we need to do is to cancel these two simultaneously. For example, sigma 0. Do I find sigma 0 here? No. So we should cancel sigma. Do I find 0 here? No. So we cancel 0. That's why we put Q0 here. Sigma 1. Do I find sigma 1 here? No. So I cancel sigma. And do I find 1 here? Yes, Q1. So I put Q1. And so on and so forth for the rest. For our transition diagram, we should base in our transition table. Q0. Q0 to Q0. 0. Q0 to Q1. 1. Okay. Q1 to Q2. Q1 to Q2. 0. 0. Q1 to Q1. Q1 to Q1. Q2 to Q3. Q2 to 0. Q2 to Q1. 1. Q3 to Q0. 0. Q3 to Q1. 1. This is our initial state, and this is our final state. Substring BAB. So what does it mean? The DFA should accept all the strings that contain string BAB. So let's get started. First, we put our mathematical model, and it consists of Q, sigma, del, Q0, F. So to get this F, we should get the Q0 is equals to initial state, Q1 is equals to substring contain B, Q2 strings contain BA, Q3 strings contain BAB. So this is our final state. For our sigma, we need to call the alphabet. So we put A and B. For our Q0, we put Q0. And for the F, we put Q3 because this is our final state. So all we need to do is to find the transition function. So for that, we create transition table. How to get this? All you need to do is to cancel these two simultaneously. For example, sigma A. Do I find sigma A here? No. So I cancel sigma. Do I find A here? No. So I cancel A. That's why we put Q0 here. Sigma B. Do I find sigma B here? No. So I cancel sigma. Do I find B here? Yes, Q1. So I put Q1 here. And so on and so forth for the rest. And we make transition diagram. To get this, we must depend on our transition table. Just an illustration of this. Okay, so for our initial state, Q0 to Q0 for our input alphabet. A. Q0 to Q1. B. Q1 to Q2. A. Q1 to Q1. B. Q2 to Q0. A. Q2 to Q3. B. Q3 to Q3. Q3 to Q3. A and B. So this is our final state.